वेलकम स्टूडेंट्स। हम डिस्कस कर रहे हैं दी नाइन्थ न्यूमेरिकल फ्रॉम दी एक्सरसाइज फॉर द चैप्टर मैकेनिकल प्रॉपर्टीज ऑफ सॉलिड। सबसे पहले हम डिस्कस करेंगे हमारा क्वेश्चन। सो द क्वेश्चन सेज अ स्टील वायर हैविंग अ क्रॉस सेक्शनल एरिया 1.2 millimeter square is stretched by a force of 120 Newton. If the lateral strain of 1.455 into 10 raised to minus 4 is produced in this wire, calculate the Poisson's ratio given that the Young's modulus, that is Y for steel, is 2 into 10 raised to 11 Newton meter square. So from the initial reading, एक चीज क्लियर है कि हमें पूछा है to find the Poisson's ratio for our wire. Also, students, you need to make one correction into your textbook. That is, the value given for the lateral strain in the textbook is wrong. So the value should be 1.455 into 10 raised to minus 4 to get the required answer. So please make that correction in your textbook as well. So सबसे पहले let's try to understand what given data is given to us. So the first quantity is given to us, that is the cross-sectional area, and we represent it using the letter capital A. And this cross-sectional area is 1.2 millimeter square. हमारा conflict number 1 यहीं पे आ गया है. Millimeter is not an SI unit, so let's convert it into an SI unit. So 10 raised to minus 3 millimeter is 1 meter. So 10 raised to minus 6 millimeter square should be 1 meter square. So 1.2 millimeter square is 1.2 into 10 raised to minus 6 meter square. Simple unitary conversion. Second quantity that's been given to us is the force on the wire, and this force का value is 120 newtons. इसके अलावा वायर पे लगने वाला हमें lateral strain given है. So the value for lateral strain on our wire is given to us as 1.455 into 10 raised to minus 4. As I said, you need to rectify this particular value in your textbooks as well, because textbook में इसकी wrong value दिया है. And the fourth quantity that's been given to us, that is the Young's modulus for our steel. So let me write it Y steel, and this value is 2 into 10 raised to 11. The units are Newton meter square. And using all this information, हमसे पूछा है to find the Poisson's ratio for our wire. So Poisson's ratio, and हम represent करते हैं Poisson's ratio with the symbol sigma. ठीक है, so this is the symbol for Poisson's ratio, and that's what we have to find. So the task सबसे पहले is to find the Poisson's ratio, and from the definition of Poisson's ratio, the formula to calculate it is, so let me write it over here. So Poisson's ratio, that is sigma, is equal to lateral strain divided by longitudinal strain. So lateral strain divided by longitudinal strain of a wire. Now lateral strain तो already given है, so वहाँ पर tension नहीं है. But what about longitudinal strain? Because longitudinal strain जैसा कुछ हमारे given data में नहीं है. So in order to calculate our Poisson's ratio, the first thing I need is to calculate longitudinal strain. So let's try to calculate our longitudinal strain. So as per the definition, the formula to calculate longitudinal strain is given from the formula of Young's modulus. So it is longitudinal stress divided by the Young's modulus, which in this case would be the Young's modulus of steel, because this wire is made up of steel. So longitudinal strength ढूंढने के लिए हमें चाहिए Young's modulus of steel, which is given. So वहाँ पर हम sorted है. Or we also need longitudinal stress, which if you see कहीं पर भी दिया नहीं है. So again, in order to calculate longitudinal strain, we need to calculate longitudinal stress first. So now let's try to calculate longitudinal stress from the definition. Longitudinal stress will be calculated using the formula force upon the cross sectional area. So एक check कर लेते हैं, force का value given है over here 120 newtons, and then cross sectional area भी given है. So that's what our flow for the numerical will be. We calculate the longitudinal stress first, then we'll use that value to calculate the longitudinal strain, and then we'll use that value to calculate the required Poisson's ratio. So iske baad, all that's left is to substitute the values in our calculation section and solve this numerical. So the first statement in our calculation section is from formula 1, which is the formula to calculate our longitudinal stress. So from this, I can say longitudinal stress is the force divided by the cross-sectional area. The value of force is 120 Newton and the cross-sectional area is 1.2 into 10 raised to minus 6. So 1.2 into 10 raised to minus 6, and as you can see 1.2, let's do some cancellation, 1.2 ones are and 1.2 hundreds are, 10 raised to minus 6 ऊपर गया, so it becomes 10 raised to plus 6, and effectively if we cancel out each other it would be 100 into 10 raised to 6, which gives us the value for longitudinal stress as 10 raised to 8 Newton meter square. That is the unit for stress. So this is the value for longitudinal stress, and let me also mark this as our equation number 1. Now what do we do? Well, हम हमारे formula 2 में इस newly calculated longitudinal stress को substitute करेंगे to calculate the longitudinal strain. So my next statement should be from formula 2 we calculate the longitudinal strain. So from formula 2 I can say longitudinal strain is equal to the longitudinal stress divided by the Young's modulus for the material steel. So let us quickly substitute the values. So from 1 we get the value of stress as 10 raised to 8, and from the given we get the value of Young's modulus, that is y of steel, as 2 into 10 raised to 11. So let me write 2 into 10 raised to 11. So 10 raised to 8 divided by 2 into 10 raised to 11 gives us so this can be written as 1 by 2 into 10 raised to 8 divided by 10 raised to 11 should be 10 raised to minus 3. So this gives us 0.5 into 10 raised to minus 3, which further gets as 5 into 10 raised to minus 4. So this is the simplified value of our longitudinal strain in our wire. And let me mark this equation as equation number 2, because we'll be using this value of calculated longitudinal strain to substitute it into the formula for Poisson's ratio to get the required Poisson's ratio. So with this, now I can say from formula number 3, I get the Poisson's ratio. So the symbol to indicate Poisson's ratio is sigma, and by definition Poisson's ratio is lateral strain divided by longitudinal strain. Okay, so let's substitute the value of lateral strain. So that's given to us, and that value was 1455, 1.455 into 10 raised to minus 4, and the value of longitudinal strain as we calculated in equation number 2 is 5 into 10 raised to minus 4. So let me also write it. We got this value of longitudinal strain from equation number 2. So one thing we can do is we can cancel 10 raised to minus 4 and 10 raised to minus 4 from numerator and denominator. And if we were to divide 1.455 by 5, so a quick division gives us this value as 0.291. So that's the value you get if you divide 1.455 by 5. And this is our Poisson's ratio. So let me just write it. So therefore, the Poisson's ratio for our wire is 0.291. And this is Poisson's ratio is a unitless quantity, as it is the ratios of two similar quantity. So no units for Poisson's ratio. If you want the PDF of the solution, make sure you check the link in the description. Have a nice day.